Hey team, it's Mr. Z, and today we're going to use polynomial long division to do what we set out to do from day one, and that's factor complex polynomials. Let's go ahead and dive on in. So I have two problems here set up, and basically I'm going to show you how to use division and use the expressions you generate to write out the dividend as the product of the divisor and the quotient. So let's go ahead and jump on in. So when we're doing this, think about what happens when we do a fact that we know well aware of. If I have $5 and I'm going to split it between two people, well, 2 times 5 is going to be 2 minus 4, and we get a remainder. There's no more numbers to bring down, so we're done. We could do decimal division if we're doing it, but we're not. So the way I write my answer, think about $5. You always go in the way of a clock, and you start out at your quotient, which is 2. You go to 1, and then you go to 1 to the 2. I call this around the world. The answer would be then, the quotient would be 2, and then 1/2. Notice how the remainder, 1, is being divided by the divisor. 2 isn't. 2 already was divided. And notice how my answer makes sense. 2.5 times 2 is 5. So all is well. So pay attention to that last sentence I said. 2.5 times 2 is equal to 5. What we did essentially was factor. Now let's go ahead and try to apply it with some variables. Step 1, look at your leading term. I see 2x to the third. I need to ask myself, x times what number is going to produce 2x to the third? So I think, and x times what is 2? Well, I need a 2. I also need 2 more x's. So I'm going to multiply 2x squared to both of my divisors. It is going to produce 2x to the third minus 8x squared, all being subtracted because we're doing long division. Okay, time to evaluate. Notice how this produces a 0, and then it's going to be plus 1x squared after I distribute the negative to the negative 8x squared. This is good. I have my new leading term. I have to figure out x times what will produce 1x squared. Well, it's going to be a 1 for sure, and then another x. So I'm going to multiply it by positive 1x. I'm going to multiply it to both parts of my divisor. 1x times x is going to be x squared. I forgot to bring down this number, negative 19x. Got ahead of myself. Now, 1x times negative 4, negative 4x. And since I'm doing long division, I subtract. 1x squared minus x squared is going to produce 0. A negative times a negative 4 is going to be positive 4. So this is going to produce negative 15x. My new leading term. Let's avoid the error of the past and bring down my number. I have to ask myself, x times what will produce negative 15x? Well, negative 15 is the missing piece. Negative 15. And I'm going to go ahead and multiply it, and I get negative 15x plus 60. But when I remember that I'm subtracting, both of these are going to turn into zeros. 0 plus 0 is just going to be 0. There are no numbers to bring down, so I have no remainder. I have no remainder. What this means, and what they want you to be able to generate, is that 2x to the third minus 7x squared minus 19x plus 60 can be factored into x minus 4 times Notice where I'm getting this. This is from the top. This is where the quotient is. Many of you would be done there, and you would be fine. But I do want you to check opportunities to factor again. In my mind's eye, I see a quadratic, so I'm going to quickly assess whether or not I can factor it further. 2x squared and negative 15. All right, I need to get a positive x from doing this. I know the factors of 15 are going to be 5 and 3. I'm going to strategically put the 3 here and the 5 there. I want it to be 2 times 3 to get to 6. 6 minus 5 is going to be 1. Notice how I used the plus x as a guidepost to factor. I want to multiply the 2x. Let me go ahead and distribute it on in. 2x times 3 is going to be 6x. Negative 5 times x is negative 5x. Notice that if I were to combine the quantities of this area model, it would produce my function exactly, which means this is a true factor. X minus 4 times 2x minus 5 times x plus 3. Always try to factor it into complete 3 parts if you can. Sometimes you won't be able to factor the quadratic as we experienced in the past, but essentially, team, this is what we're doing. Notice I have 3 factors, 3 groups. It is degree 3. All is well in the world. So this is how you can use long division to factor. You're trying to get it to be in a quadratic, which means degree 2, like in the what I underlined in orange, so that I can maybe factor it more. Let's do one more. So I ask myself again, I need to figure out x times what will produce my leading term x to the third. Well, 2 x's are missing. So I'm going to multiply x squared to both my x and my 3. This is going to produce x to the third plus 3x squared. I have to remember I'm doing long division, so I'm going to subtract. Well, this is going to produce 0 plus 5x squared. I have to bring down my number now. Well, let's bring down the 7x. Now I have to ask myself, how am I going to make 5x squared? My leading term is x. So what's missing? Well, 5 is missing and an x. Notice it's a positive 5x. That's where I got the plus sign from. It's a positive 5x. Now, rinse and repeat. 5x times x is going to be 5x squared. 5x times 3 is going to be 15x. I have to remember I'm doing long division, so I'm subtracting whatever I multiply. Notice it's going to form 0 minus 8x. These zeros are indicators that you're doing it correctly. Okay, negative 8x. Bring down the last number, plus 5. I have to ask myself, how do I make a negative 8x when my leading term is x? X times what? Well, what's missing? Negative 8. Negative 8. I'm going to distribute it. So it's going to turn into negative 8x minus 24. And I have to remember I'm subtracting. This is going to be 0. And then it's going to turn into 29, which means I have a remainder of 29. Okay, just to review, x plus 3 is not a linear factor of x to the third plus 8x squared plus 7x plus 5. This is using the remainder theorem. However, the instructions wanted us to write it as the product. Remember, when you're doing something, your quotient is equal to the divisor times, no, scratch it. Let me phrase it this way. So we got 29. Look up above. Do you notice how we did that around the world bit? This is how we're going to end it. 29 is part of our answer, but it isn't just going to be R29. In the past, you might have written it like this. Instead, I want you to think around the world. So you're going to go boom, clockwise, boom, boom. And the reason I do that is x squared plus 5x minus 8. And then what is the remainder? Well, the remainder is 29 over x plus 3. The 29 still has to be divided by x plus 3. The number after the whole number, the negative 8, is going to be the remainder. It is not nice. The reason it's not nice is because it is not a linear factor. So hence I'm going to have a fraction. Even though it's a fraction with a variable, it is no different than up above getting 2.5. So this, my quotient multiplied by my divisor, will produce the original guy. This is what you're trying to take away from this section. If you multiply your answer in the divisor, you should get the dividend. Again, your quotient times the divisor should equal the dividend, what you divided. I hope this helped. I wanted to do one problem with a remainder and one problem without a remainder. And just remember, all around the world, and think, what way does a clock tick? Clockwise. That's how I do it. That's it for now.